consultants are based in the UK and Europe. We focus typically on consultancy, so the major bulk of our services is data engineering in that consultancy environment, and we work with key industries such as small to medium-sized business, finance and insurance. So probably next slide, Stefan. So what do we actually do? Well, when you want to implement something and get value from analytics, you need the strategy. So that includes defining and planning what you're doing and having the capabilities to understand how to take your business from what it wants to achieve to the actual applications and solutions that will do that. As we've worked in this environment for a long time, a lot of the low-hanging fruit is in typical traditional dashboarding and self-service. So we do that as part of the business. As companies have grown IT over the years from on-prem to cloud, we do a lot of work helping our SaaS customers modernize and take their SaaS versions to SaaS Fire and cloudifications to take those platforms to the cloud. We do all the monitoring and health checks to make sure that's optimized for you. And as customers go to the cloud, we typically provide services around hosting and managed service support to enable them to keep the lights on, keep the business running while they control the data. We look after the services and applications behind that. Just a quick look at our ecosystem here. We're partners of SAS, Microsoft, AWS, and also Matillion, which we think's good in certain parts of the business. We've also worked extensively out in Europe with our partner LACO, and as you can see from our customer base, it varies quite widely from private sector, so companies like the AA or AXA, and also government. So we do work with the Department of Work and Pensions and the university space. We've also got small businesses like Golden Charter and very large companies like IMEC. So a really widespread of customers and partners. So at this moment, I'd like to introduce my colleague Stefan to go through the background and project goals that we've got today. Thank you.
Thank you, Steve. Welcome to our webinar from me too. My name is Stefan Stoyanov. I'm an associate data scientist at Analytium, and I really like helping our customers to get the most of their analytics in the cloud. Now I would like to present to you a typical scenario where a company would like and would want to migrate their SaaS assets from mainframe to another system. Usually, such companies, they have multiple mainframes and with a lot of many SaaS applications, but these multiple mainframes increase the total cost of ownership. Also, sometimes this company already started investing in new SaaS assets, for example, SAS Via, which is on Linux, and that's why they would like to migrate SaaS from mainframe on Unix to achieve a single, to unify all their SaaS assets in a single SaaS platform, to modernize some of these assets, for example, legacy SAS AF application, which needs to be modernized, and to use the benefits in the cloud where they can scale up and scale down resources, so to optimize the total cost of ownership. And then the goal of before starting the migration is to assess the feasibility to migrate from SaaS on mainframe to SaaS on Unix. And to achieve this goal, to do this assessment, we have a scope and a few criteria that good practices to focus on in order to make a successful assessment of the migration effort. So the scope is companies would like to migrate their SAS applications and their SAS code and SAS datasets. And also part of the scope of the assessment is a possible optimal target SAS migration environment. We typically focus on three main criteria which help us to drive a successful assessment. At the end of the assessment, we need to come with a successful migration approach that will ensure fast and efficient code migration, but also minimal business impact, which means no or minimal disruption of the business activities during migration. One of the other criteria that we're focusing on is savings, both to minimize the migration costs and also to optimize SAS licenses by unifying all the SAS assets in a single platform, which will, of course, reduce the total cost of ownership. And another important criteria here is to achieve some extent automation of both the assessment process in the migration of the SAS assets to the new platform, and to come with a realistic, efficient timeline for the migration process. Here I would like to provide you with a high overview of what a current versus target environment would look like in such typical project. So the SAS environment, usually we have one or more mainframes where we have a data store with different text data files, other code, but also there is the SAS code and the SAS assets. And this mainframe is connected with the SAS analytics platform, the mainframe, communicating with the data store. But quite often, before starting the assessment, many of our customers already have invested in some SAS assets on Unix. For example, they started exploring SAS via, for example. And as you can see, we have multiple environments here, which is hard to manage and increases the total cost of ownership. That's why we would like to go from this state of the environments to the target environment, which means that we are going to migrate the SAS assets from mainframe and unify all the SAS assets into a single SAS Unix platform in the cloud. And on the mainframe instead, in the data store, we don't have SAS code anymore. So what to look for at the program level when we start assessment, a best practice is to look at several things: the source data and code, which includes text files, SAS code, and other code. Things like the scheduling mechanism. For example, on mainframe, the native scheduling mechanism is JCL, but when we migrate the SAS from mainframe on Unix, for example, on SAS via, the companies would need to know what they need to change. So they need to build their scheduling mechanism in SAS via using SAS scheduler. We look also into a mainframe interfaces and a non-standard tech, for example, which comes to an end of support from SAS, for example, SAS AF applications, and to see how many of these applications needs to be modernized to build new applications. And we look also at the SAS licenses, for example, when migrating to the new platform. what of the if there's need for new functionalities or any changes of the existing functionalities. As I mentioned, for example, the customer would maybe need to modernize their SAS AF legacy applications. And by the way, at Analytium, we also provide such a service to our customers to help them build their new modern SAS applications. And here I would like to hand it over to my colleague Pavel, who would provide you more details about what to look for at the program level.
Yeah, thank you, Stefan. Yes, my name is Pavel Rogic, and I'm a senior data scientist here at Analytium. And yes, we'll talk about what to look for in programs. And when considering migration from SAS on mainframes to SAS on Unix, there's a natural question. Will all SAS programs that run on mainframes work in the new environment and produce the same results? And while probably most of the SAS code will not require any changes after migration, still SAS language has some features that are specific for ZOS, which is an operating system for mainframes. And these specific features of SAS for ZOS must be dealt with because they can cause programs fail or work as not expected on a new platform. So features that are specific for ZOS can be found in functions and call routines. Then in macros, for example, macro statements, macro functions, automatic macro variables, global macro variables. Then in elements that rely on the sort sequence, we'll talk more about it later. Then these specific features can be found in formats and in formats, procedures, statements, data set options, system options, as well as other elements like job control language, JCL, which is a part of mainframe, and it can be mixed with SAS code in programs. Yeah, I already mentioned some other elements that are specific to ZOS. And here are just a few examples I want to mention. For example, TSO function in SAS for ZOS issues an operating environment command during a SAS session. But under an operating environment other than ZOS, the TSO function has no effect. And another example that some procedures, SAS procedures that work in SAS for ZOS are meaningless in Unix, while other procedures need to be used differently. For example, proc PDS is used in ZOS to list, delete, or rename members of a partitioned data set, or PDS, which are libraries that contain files called members. So proc PDS is used in ZOS, but cannot be used in SAS on Unix. Also, mainframes use so-called EBCDIC coded character set, while most of other computer systems use the ASCII coded character set. For example, in modern times, ASCII is a subset of Unicode. So one of the differences between these coded character sets is the way they assign bits for specific characters. Also, each character set has a collating sequence, and the collating sequence is important for sorting and for almost any program that scans and manipulates character strings. EBCDIC and ASCII collating sequences are different. For example, lowercase a is less than capital A in EBCDIC, but greater than capital A in ASCII. Then numeric characters are less or go before than any alphabetic letter in ASCII, but are greater, so they go after than any letter in EBCDIC. So everything that relies on the ordering of characters in the encoding needs to be revised for migration from mainframes to Unix. And examples of differences going on. So before migration, migrating all SAS programs must be revised. Of course, it cannot be easily done manually. So this is the reason we developed and use SAS code parser for scanning all programs that need to be migrated. And SAS code parser is a Python script that was developed to analyze SAS code complexity for migration. It also was used to define relationships between code and data sets that are used and produced during processing. SAS code parser helps to find those issues that we just showed you on the previous slide. So SAS code parser allows to plan migration better because it gives an understanding of how many programs need to be changed for migration, how many potential issues these programs contain, and what these issues are. This parser helps to minimize risk of migration because it gives information which will be used to make a decision about migration. It helps also to automate, of course, the process of assessment by scanning all SAS programs for potential issues. And it presents a report of SAS code changes that may be required during migration. And it gathers information about SAS code characteristics, for example, frequency of code elements and files that are referenced in the code. And it can be adapted to clients' needs to scan for very specific information in SAS code. It could be hard-coded paths, it could be specific options, file names, etc. And very important, with extended functionality, it can be used to make necessary code changes during migration. And next, we will show an example of the SAS code parser results.
Thank you, Pavel. And here is an example of a dashboard that we create for our customers. One of many dashboards that customize according to their needs and their desire to present results from the SAS code parser. For example, you can see here that we have a few mainframe all parts. You see the total files, the files that require intervention, the number of issue instances that need some revision and changes, issues to change. Here it's blurred because it's from a real customer project, but we can provide the paths to the files, the type of issues and their frequency and the number of files they appear. And for example, the top issues, 10 issues by count, and so. But this is just an example of a dashboard, and it can be customized like a report with many other pages, depending on the project and the needs of the clients and the findings from the SAS code parser. We also built a visualization tool to visualize interactively the network, as a network, the links between SAS source code files and different data sets that are produced by this SAS code. For example, here's an example of a SAS AF application source code network, and it's blurred again because it has confidential information from a customer, but you could see the links between programs and different data, other programs and different data files that are produced by the SAS code. So really powerful and insightful tool to help help with the assessment and of what the effort would be for migrating and modernizing your assets on the new platform. And of course, at the end of the our assessment project, we have a few deliverables that we provide to our customers as the migration plan, which includes the best approach for migration that minimizes cost and also estimated cost and timeline for this migration, a high-level business plan to answer the business requirements, needs, and goals, and architecture, the target environment architecture of the new platform. So once the migration assessment has been done, what are the typical next steps? We work with our clients where we can create a proof of concepts, deliver a proof of concept to confirm the migration approach and target architecture to check that everything will work fine. And then the next step is to implement a pilot project where we have a preparation phase where we set up the infrastructure, also install and configure the SAS software, and configure our SAS migration tool, which help the migration process by automating, as Pavel mentioned, the modifications of SAS code functions, for example, procedures, lib names, to speed up and the migration process and reduce the cost of the migration. And then we will implement the migration itself by deploying run and comparing the SAS code and data to what it was like before the modification, for example, and after the modification. And at the end, we will perform tests and implement end-user validation through shadow run, which will confirm that the modification, the migration was successful. And this